Hello, welcome back to the continuing lecture in Principles of Finance. Um, we've been talking about the stock valuation models for the last couple of sessions, and what we are going to talk about is the product life cycle, the variable growth model, and which is basically um, reflecting the product life cycle theory. So let's go into an example, and we discussed the background of the variable growth model in the last class. So let's move on to the example. So let's take a look at this. Most recent annual dividend payment of Warren Industries, a rapidly growing boat manufacturer, was $1.50 per share. So you need to parse parse is the computer computer science term or computer engineering term, where you actually break down, analyze, and break down. So we need to parse the narrative, because, as I said, lots of times, oftentimes the narrative is there's a lot of fluff in the narrative, and you need to you should be able to crystallize it down to the gist, very gist, right? Boil it down to the very gist, not just 2012 is the most recent year. That means we are at the end of 2012 or at the beginning of 2013. But for us, because we are more, end of 2012 is the same thing as the beginning of 2013. And let's to have received the 2012 dividend. Of course, dividend is quarterly, but we're assuming dividend is annual in this example. Now, you cannot receive 2012 dividend during 2012. It goes without saying. 2012 have to end, right? 2012 has to end to receive the dividend. So that means we're already past that point. And usually the dividends are paid in the middle of the following quarter, right? The dividend that is being paid is, always the dividend from the previous quarter. So just like that, we can assume that the annual dividend of 2012, which is the most recent dividend, which is time zero, dividend at time zero. And if we received it, then that means we are already at some point in early 2013. But that's not really the critical thing. I mean, that's basically what we need to have as given. Now, they paid $1.50, right? That's the most recent dividend, and dividend at time zero. And it says the name of the company doesn't matter, right? Warren Industries. Boat manufacturer, which industry it is in, it's less important at this point, right? But one thing you have to focus on is the fact that it is rapidly growing. Now, remember, if it is rapidly growing, there is a phase where it is growing at rapid, right? You see this, cursor moving. I hope you can see this cursor moving. There is, a fast growth phase, and then slower growth phase, right? So if it says, rapidly growing company, then that means there will be in the later there will be a slow or constant growth phase later. So the firm's financial manager expects that the dividends will increase at a 10% annual rate, G1. That wasn't G1 in the original verbiage. I put it there to distinguish between fast growth and slow. So dividends will grow at 10% annual rate over the next 3 years. So the next 3 years will be the fast growth phase. At the end of 3 years, the firm's mature product line, now they say it's mature. Mature means, now the growth will now slow down, right? Mature product line is expected to result in a slowing of the dividend growth rate to 5% a year, G2, right? Second growth rate, for the foreseeable future. For the foreseeable future is just another way of saying indefinitely, right? Now, you say, oh, indefinite, clearly they mean the different thing. Indefinitely, that means forever. Foreseeable future. What is foreseeable future? It seems like it's smaller time frame, short time frame than indefinite time frame. But as far as the forecasting is concerned, you don't have, foreseeable future means, as far as your forecasting ability goes. And then beyond the forecasting ability, anyway, that is, there's no way you can make forecasts beyond that time horizon. So indefinitely is a foreseeable future. Indefinitely basically mean practically the same thing. Okay, because beyond indefinite future means indefinitely within our forecasting ability. Now, so what does this tell us to do? Well, I'll get to that. We need one more thing. A firm's required return is 15%. Required return is the discount rate. And for now, it is given. We take it as given, but in reality, nothing is given. You'll have to figure it out from the data, given data, right? So, but we'll take it as given. So they have, okay, in the slide, they it's done this way, but I did it in Excel, and I will show you. I did it in Excel like this, so I will show you. So let's go to Excel first. I'm gonna have to stop sharing, and then all right. So we're in Excel. So let's go to. So here's what I did for that given example. So let me blow it up a little. So it's a variable growth model is actually a two-step model. Okay, two-step. Why? Do I need to do? Okay, good. First, so the most current is 2012, and most current dividend is $1.50, right? It's time zero, right? And dividend growth rate for the last 3 years is 10%. So what do? I can forecast dividend in time 1, time 2, time 3. Time 1 is of course 2013. How did I do that? Of course, making just 1 year forecast by 1 year compounding, right? So what I did was C27 is this, right? I lock it because I'm going to drag it down, and then D27 is the growth rate. I lock it, right? So I can drag it down, and then raise to the times digit, right? And then I drag it down. It generates future for 3 years, next 3 years, the dividends. And then valuation is always what? The valuation is always the present value. So we will need the present values of these. So present value is basically what? You will need to discount it, right? So the discount rate is 15%. So I will discount it by, so I lock, discount rate and 8, by 1. You might say, oh, why do we do that? 1, it doesn't do anything. It doesn't matter. I mean, it may be 1 for this one, but it will come in handy when I get down, right? So there you go. And then I drag it down. Okay. And then I do the same thing, as I drag it down, right? So I have the present values of all these future dividends, and I sum, right? The present value of all of those dividends are like this. But that's not the only thing. That's the present value of all those dividends during the fast growth phase. But beyond that, beyond the fast growth phase, when the growth rate settles to 5%, what do we do? I mean, there will be dividends growing at 5%, and there will the future value of the but first of all, let's think about it. Beyond 2015, that means from 2016 and indefinitely, the dividend grows at a constant rate. Look, this is the cue. Constant rate means what? Oh, that means, Gordon growth model or constant growth model. Make sense? In other words, beyond 2015, the valuation of, we will need to find the valuation of this stock, right? As of the end of 2015, right? Which, 2000. So for stock valuation, to apply the Gordon growth model here, right? The time zero will have to, the time zero will be 2000, end of 2015, right? For the second period, for the slow growth period, right? Constant growth period. So we know the growth rate, we know the required return. We can calculate the stock price as of the end of 2015, right? That's why I put it like this: price of the stock as of end of 2015. So using Gordon growth model, and then because we know the growth rate of the second phase, which is 2016 and after. I mean 2000 past after 2015. Then we can make a forecast 2016 dividend, which is simply this times 1 plus this, right? 2016 dividend will be like that. There you go. Then using Gordon growth model, to dividend at time t plus 1, which is this, over R minus G. Okay, then we got stock price as of the end of 2015. But again, 2015 is not where we are. We are at what point? We are at the end of this time zero is where we are, isn't it right? We're at the end of 2015. We're slightly past that. So then this is like end of 2015 value. So what do we need to do? We will need to discount it back to 2012, which is 3 years back. So what do? We discount it, right, by of course, R raised to 3 years, 3 years back, right? Makes sense. Then we get the price of this stock as of the value of 2000 value of this stock as at the end of 2012 is this 13.78. But at the end of 2015, it's not only that. I mean, this is only the present. This is only the present value of all the cash flows beyond 2015. What about the cash flows between now and end of 2015? Well, we already got that, right? Present value of all those is 412, and present value of this is 1378. So the actually the stock price at the end of 2012 is the sum of these two. Make sense? We got it. So 1790, that's to be exact, right? The book is rounded. The book is rounded numbers, so you get the rounded values. As let's see, 18. It gives you 1793, but exact one is 1790. Okay, now so this is the third model. Let me stop sharing the Excel file and go back to the PowerPoint. All right, here it is. So this is the third model, right? Remember, stock valuation models have there are four models. This is the third model, variable growth model. Then what is the fourth model? Fourth model is called free cash flow model. Free cash flow. Now, what is free cash flow? First of all, we've been assuming dividend is the cash flow. In case of dividend is the cash flow in stock. But then think about it. So the stock valuation models are called, I told you, DDM, dividend discount model. But what if the dividend? Some companies, some companies don't pay dividends, right? Companies pay dividends, but they may skip the dividends for a number of years, right? And then resume the dividend again, dividend payout. But some companies don't pay dividends. So if this is the case, how do you value those companies? In other words, dividend discount model is useless, right? Dividend discount model breaks down when there is no dividend, right? Then how do you model the companies that don't pay dividends? How do you right? How do you value the stocks of the companies that don't pay dividends? Again, then then we'll have to will need something that don't depend on dividends. And so the only other option, the best alternative, is free cash flow. And what is free cash flow then? Free cash flow sounds like a very liberal thing, liberally defined because the name is free. But free cash flow is not really liberally defined, but it's very rigorously defined. So let's define. Let's understand what free cash flow is first. Um, uh, actually, free cash flow is defined verbally in so many ways. They say cash generated beyond reinvestment needs, net cash flow less non-operating cash requirements. So what are those? It's not really. It's all very foggy, nebulous, right? That's why I don't like verbal definition because day one I said, I don't, verbal definition is not infallible, right? It's there's always, it leaves, room for um, different personal interpretations. So if it is defined like that, it is useless. The best definition is always the mathematical definition because it's indisputable, right? There's no room for any subjective interpretation. So mathematical definition of the free cash flow is like this. Free cash flow is equal to operating cash flow minus investment in operating capital. So then what is operating cash flow? Operating cash flow is defined as EBIT minus taxes plus depreciation. Okay. And investment in operating capital means, operating capital, comes in two parts, right? Look, your fixed assets or non-current assets, right? Those are the physical capital or physical assets, right? There will be change in physical capital, physical assets, right? Over time, you add more. I mean, first of all, the value of your physical assets would change, mainly because it will go down in value due to depreciation. I mean, it's inevitable because of the wear and tear of the equipment due to usage over time. The aging, of the physical assets have to bring down the valuation of the physical assets. Anyway, it's getting old, so it's with usage, it gets less and less productive because of wear and tear, right? And it will you will the management won't just watch it hands down, right? When the production capacity goes down, they won't just watch it hands down. They will replace the worn out portion of the capital, right? So they will try to maintain the original production capacity or even more, even want to raise it to a higher level. If the economy is good, the demand will increase, so they will need to increase the production capacity, right? So there will be a change in fixed assets. And what's the other part of what's the other counterpart to fixed assets? It's working capital or current assets, right? Current assets will also is constantly in flux, right? So there will be a change in current assets, but net working capital. Current asset is called working capital. Net working capital is the basically the net. In other words, current assets minus current liabilities is called net working capital. Okay. So that is the investment in operating capital, operating cash flow. What now? Operating cash flow. That name, that word sounds a kind of familiar. Why? You know what is operating income or operating profit, right? Okay. Uh, but isn't operating cash flow similar to operating profit or operating income? No, slightly different. Why? Why? Why not? Why is it not the same? First of all, this is the operating income, isn't it right? EBIT is another name for operating income. But then operating. So how is it different from operating cash flow? It is different. It is different by as much as this minus taxes and plus depreciation. So first of all, not the not all of the EBIT is uh, cash cash flow to you. Why? Because uh, taxes you can't touch it. That's something you owe the government, so you can't touch it. It's not um, and normally interest is also it belongs to the lenders or the creditors. So interest uh, is usually not something you can dispose of, something you can dispose at your own will. But there can be no interest payment. There can be no interest expense, right? There's a why? If you don't have any debt in your capital structure, right? There's no interest. Anyway, even if that's the case, uh, interest is not untouchable, right? Uh, so only taxes are subtracted from it. But then, why do you add depreciation there? I mean, isn't it already subtracted in the um, isn't it already subtracted from the balance sheet? Because depreciation is first shown in the balance sheet. Why? Because in the fixed assets, right? In the fixed assets section, uh, you have plant and equipment, right? Land and building, right? Those are mainly your fixed assets. And last item is depreciation. Of course, depreciation is a minus, negative number in the balance sheet because it has to bring down, it has to bring down the value of the fixed assets. But then it's also appearing in the income statement as part of the operating expenses. But think about it. This operate in when it appears in the operating expenses, right? This is actually a phantom. Phantom. Why? We had when we went over um, the financial statements, we didn't have much time to talk about depreciation. But, we may have. I just can't um, trace back to when we did the income statement and balance sheet. But I told you that depreciation is also something like this. Of course, it reflects the declining book value of the assets. Small, but get, uh, for for business assets, right? For business assets, depreciation is totally optional. It's not really following. It follows artificial schedule, and it has nothing to do with uh, the actual resale value. So this way, the company, say the company bought a car. You pay $50,000 upfront. There are some ways you can pay for the car. You can pay cash, lump sum cash, and then you can finance it. I mean, of course, financing is more, rational. Assume that you pay for cash, right? Lump $50,000. This company, also as a company, it's a business asset, right? So this will be, just like a plant and equipment, right? It will depreciate, and also, so you paid $50,000. Let's say you bought it on January 1st, so it's time zero, right? Time zero of the first year, right? January 1st. And since you paid 50K in lump sum cash, right? You will write it off as expense in the income statement, don't you? You will, yes, you will have to write it off as business expense. You'll write off 50,000 in year one. Normally, that's what you would think, right? That's what go. But then think about it. IRS doesn't want you to do it this way, and I'm not going to go over the rationale behind it. But IRS want, because if you write off 50,000, that does that mean EBIT goes down by 50,000. If EBIT goes down by 50,000, that means EBT will go down by 50,000 as well. That means EBT is the tax base for the IRS. Now, that means what? As EBT goes down by 50K, then which is the taxable income, the tax will go down by 50%, by as much, right? It's not exactly 50,000, but if the tax rate is 40% of 50,000, it will go down by as much as that. So IRS doesn't want you to write it off in year one. Instead, they will want you to write it off spread over 5 years, for example, 5 years. So that means each year 10K, 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 right? So think about it. In year one, you're writing off only, although you actually $50,000, you're writing off only 10,000 in the first year. And year two, from year 2 through year 5, you write off $10,000 every year, but you didn't incur that expense in year 2 through year 5. You never incurred them in those years. So from year 2 through year 5, actually, these are expenses that never happened. That's why it's called, also non-cash layout. There was no actual cash payment, but you write off 10K as if you actually spent 10K, whereas you didn't. Then what does that create? What does that do? It creates a phantom expense, right? A hollow expense that really didn't exist. That just contributes to reducing your EBIT, which will reduce your EBT by 10K from year 2 through year 4, right? Which will reduce your taxes by as much, right? So in other words, this is like from year 2 through year 4, the depreciation is like giving you a cash back, because it's like preserving $10,000, right? From saving it from taxable income, saving it from taxes, because as much as $10,000 in year 2, 3, year 4 was not spent, but it was showing as if it was spent. So it's like um, preserving $10,000 each year. So, right? So that adds to the cash flow. Makes sense? So that's why I add it back. Now then, think about it. This is the cash flow generated from operating activity, right? And then if there is any need for increase or decrease, increase, the changes, increase or decrease, changes, in operating capital, that should come out of where? It should come from your operating cash flow. That's what is meant by net cash flow less non-operating cash requirements, right? Net cash flow less or cash generated beyond reinvestment needs. These are reinvestment needs, isn't that right? Changing gross fixed asset means, if you expand your production capacity, right? More plant and equipment, right? There's, additional reinvestment, right? Additional investment. Beyond that, right? Cash generation. So this is literally, now free to the free for the owners, free to the owners to spend as they please, right? That's why it's called free cash flow. Okay, but free cash flow is really, really, rigorously defined. Okay, so with that in mind, so we understand now what free cash flow is, and since the company doesn't pay dividend, the cash flow we need to consider for such a company is free cash flow. Now, and then think about it. Free cash flows are all basically, future cash flows, right? So we have to discount it back to present. All these free cash flows, going all the way to infinity, the stream of, future cash flows, right? We have to discount it. And if we discount it, that result is, that's the value of the company. Think about it. What is the value of the company? I've been telling you the value of the company is generally, the book value of the company, book value, right? The value of the company is what? Total asset value, isn't that right? Total asset, because total assets is equity plus total debt. And equity plus total debt is defines the size of the company, because total assets comes from equity and debt, and with the total, it's that with the equity and debt, you acquire assets like fixed assets, plant and equipment, land and building, and the current assets, right? So, but that is based on the book value. And I told you, book value is always based on the past data, right? There's no way you can. Book value is always, no matter how updated, up to date it may be, book value is always based on the most recent one. Most recent one is always past, because we barely have first quarter data coming in, because we are in May. So actually in April we got the first quarter data in. So we are already in May, and the first quarter is already 1 month behind. So the first quarter data is already passed, but that's the most recent data, right? So but then value of the company based on the book data is, as I said, it's not the most, it's not the current value, right? So current value, you must use, what is the rational intrinsic value? It's always discounting the future cash flow, right? So the value of the company is actually its present value of all its earnings power, future cash flow, right? So this is the intrinsic value of the company, or the rational uh, value of the company, right? Or fair value of the company, not the book value, right? Now I've been telling you there are three valuations, three types of values. One is book value, the other one is intrinsic value, the other one is market value. And I've been telling you, market value is, in the short run, irrational. Book value is past. Now, if the market is in equilibrium, the market value is equal to the intrinsic value, right? Makes sense. So that's that's what we need, the intrinsic value. But if we have intrinsic value, then that is not the stock. Why? Uh, Stock is, basically equity, right? And you understand just like total assets. This is basically the workings of the value, current value of the company as the result of the workings of the total assets. But we understand the total assets consist of equity and debt. And equity breaks down into a common stock and preferred stock. So the idea is value of the company is the a sum of the value of the common stock, value of the preferred stock, and value of the debt. So let me use the whiteboard. Let me go back and okay. If I go to the whiteboard, right? Oops, what happened? So the value of company, right, is equal to the value of the common stock plus value of the preferred stock and the value of the debt, right? So this is like, the balance sheet. This is what? Equity. And this is debt, right? This is like total assets. But once again, total assets is simply, based on the past data, actual capital raised. But, this is based on earnings power in the future, right? Future cash flow. So then we are not solving for this. We are actually, we are interested in this. So value of the common stock is then, value of the common stock is, then value of the company minus value of the preferred stock and the value of the debt. Right? Makes sense. So we can isolate value of the common stock. But then this is the aggregate value. In other words, value of, if there are like 1 million shares outstanding, right? 1 million shares of common stock outstanding, and each share is $10, right? I mean, the total amount of the equity, total value of equity is 10 million. What does that mean? What does that tell you about the price per share? Of course, we know price per share is $10 because if the total equity is 10 million and there are 1 million shares outstanding, simply divide it by 1 million, right? $10, right? So price per share. So if we call that S0, right? Now, of course, book value is like book value per share, but the only reason I'm not calling it book value per share is this is not past data. This is not based on the past data, right? This is based on the future cash flow. So yeah, then all you need to do is simply divide value of the common stock by number of shares outstanding. Okay, number of shares. All righty. So now let me get back to okay. So you get the idea why, when we arrive at this, then we divide it by number. But then the next question is, what do we use as the discount rate? That's the critical question. Why? What is the discount rate that we need to use? Oh, isn't that the required return that's normally given? No, no. First of all, required return won't be given. I mean, normally you'll have to figure out. This is just a very basic example, so very rudimentary example. So required return was given, but in real, it's not going to be given. And two, this free cash flow is like the fruit of the tree. Now think about it. The tree is the company, right? And free cash flow is the fruit borne by these trees. And think about it. The tree consists of common stock, preferred stock, and bond, the debt, right? The tree consists of these three components, right? Tree is the the tree bear fruits, right? The fruit is the result of the workings of the um, common stock, preferred stock, and debt. Make sense? So then, if it is only common stock that contributed to bearing these fruits, then you discount it by the appropriate discount rate, the required return for the stock, right? And if it was the fruit is the result of only the workings of only the bond, then debt, you discount it with the cost of debt, right? The yield, right? But then you understand this is the fruit is the result of the combination of the workings of equity and debt. And what do you use as the discount rate? That's where the weighted average comes in, capital structure comes in. Think about it. If the capital structure is 60% equity, 40% debt, we can reasonably assume that 60% the fruit is the result, the harvest of the fruit is the result of the contribution, 60% contribution, the contribution of these uh, uh, bond and stocks are exactly in the proportion of the capital structure, right? So the contribution is, to this fruit is from 60% from equity and 40 from debt, right? Makes sense. And if the equity once again breaks down into common stock and preferred stock, and also the proportion of common stock and preferred stock, usually, so anyway, so let me. So that's called so in other words, what you need to do is the capital structure. In other words, equity ratio, right? 60% times required return plus the debt ratio, 40% times the cost of debt, right? And that is called weighted average cost of capital. So this RA represents weighted average cost of capital, right? Let me use that. Okay, try. So what that means is, what is weighted average cost of capital? Weighted average cost of capital is weight of equity times cost of equity, which is the required return, plus weight of debt times cost of debt. That's that, right? That's weighted average cost of capital, okay? Now, so then, this is also a kind of multi-step model. Why? Let's take a look. So let's take a look at this example. Dewhurst Inc.'s data for the free cash flow valuation model. First of all, we have the free cash flow forecast from 2013 through 2017. So 4 years, right? For the next 5 years, actually, forecast, for 5 years. And then, so there is no dividend data because this company isn't paying dividend. Other data, the growth rate of free cash flow beyond 2017 to infinity, growth rate of cash flow is 3%. That means, beyond 2017, you will, what does that mean? You will apply 3% to this, and then that will be the 2018, and right? And so on, right? And they gave you weighted average cost of capital as 9%. It's already given, so makes it easy. So value of debt, 3.1 million. Value of preferred stock, 100,000. I mean, if they wanted to make this example very hard, they would have done it. They would have made it very hard, and they would really give you a hard time. But they wouldn't even give you the weighted average cost of capital is given. They would make you calculate it, actually, based on the capital structure. And the number of shares outstanding, common stock, right? Number of shares of common stock outstanding, 300,000. So it's almost, served on a silver platter. Everything is, provided. All you need to do is, and from this, how do you proceed from here? Look, this is the clue. Growth rate beyond 2017 to infinity. That means what? And is constant at 3%. Growth rate of free cash flow, constant, 3%. Doesn't that ring a bell? Although this is not dividend, but it's the golden growth model. It's the same pattern, right? Golden growth model. So that means use golden growth model beyond 2017, right? Right after 2017, right? Use the golden growth model, and for the next 5 years, the cash flow is projected and is given to you. So what do you need to do? Just like in the variable growth model, you find the present values of these and combine it with the golden growth model, right? And then that's the value of the company. Well, you discount it all the way back to 2012. That's the value of the company as of 2012. And then what do you need to do? You will need to then isolate only the value of the common stock, and then that's the value of the equity, common equity, aggregate, and then to find the price per share, you divide it by number of shares, right? So they did it, in the slide. A lot of things were done there, but let me quickly. What's important is do it using Excel. So let me. So it's pretty much like the variable growth model example, right? First of all, year 1 through year 5, free cash flow, I discounted it to present. I found the present values, right? So then you might wonder, present values there, but why are they in? Why the projected cash flow duplicate there? Well, it was a duplicate, right? I had to make a duplicate because of this. You will see year 5, it's not a duplicate. Why? Then it is, suddenly different. Why? It's because of this. Now let's see why. So first, we need to find the present values of all these free cash flows. Step 2, then we need to forecast the free cash flow in 2007. Why? Because we're going to use Golden Growth Model. We need one more year on time t plus 1. And since it grows at 3% constantly, at a constant rate of 3%, then all you need to do is this times 1.03. There you go. And then using Golden Growth Model, we know that's the required return, or weighted average cost of capital. So dividend at time t plus 1, it's not dividend, but free cash flow at time t plus 1 there, over R minus G, right? R minus G. So then what is that? That's the value of the company at the end of 2017. In other words, that's the value of all the free cash flows 2018 and beyond, 2000 and forward, discounted back to the end of 2017. Okay, so that's 10.3 million. Now, since this is 2017 value, right? End of 2017 value, that belongs here. So I added it. Right? This is free cash flow 2017. So they are both 2017 values. So added them, right? And then found the present values of all of them. Simply, we know the technique, right? That was, used in. So, and drag down. And then finally, I sum it all, right? Sum it all. And then, so that's the value of the company as of 2017, end of 2017, right? Value of the company. So that's the value of the company, right? And it's not 2000. In other words, 2012 value of the company, right? 2012, end of 2012 value of the company. So value of the company. So then what is the value of the common stocks? Of course, then we must subtract value of the debt, value of the preferred stock. So there you go. Okay, value of the, from this, I take away some of these two, and then I'm left with, so this is the aggregate value of the common stock, or the equity, common equity. And then to find the per share value, I divide it by number of shares. divided by number of shares, and voila, that's the intrinsic value of the stock, per share value of the stock, right? Okay, this is the free cash flow model. And you can tell free cash flow model in this case is like an external variable growth model. Yeah, that's specifically this. All right. So then that brings us back to oh, I don't know if you were able to see. Let me see what's in the. Oh, no, 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 no. Oh, God. You were still watching this. Ah, okay. So let me, I'll have to redo this. Okay. So this is it. I've been just projecting the, I guess I've been just projecting uh, the PowerPoint slide. So look, once again, the free cash flows. I turn them into present values, right? Well, again, this column seems like a duplicate, but it's not a duplicate. It's a duplicate, but just because of this, in 2017, that's not the only cash flow. 2017, there is 2017 value of all the cash flows beyond 2018 and beyond, right? Which was found by Golden Growth Model, right? So that's why the F column, F45 is this. And I find the present values of all of them, right? Which is, simple, present value. And then you arrive at a sum all of it, right? And then since this is the 2012 value of the company, so this is 2012 value of the company, and from that you subtract this and this, right? Then that's the value of the common stock, right? Value of the equity, common equity. It's an aggregated value. So if you divide this by the number of shares, that's the per share value, right? Okay, so this is the so we need just a little more, right? I guess we're almost there. So that's free cash flow model, right? And then I don't think how much time has. I don't think we have time for this today, but how much time? Let me check. All right, I guess we I think we'll have to continue with the. Oops, you don't see. I don't think you can see this either currently. Oh, it's frozen. This thing is frozen. Okay. Yeah. So then our next question is, the stock valuation model is, called discounted cash flow model. I mean, specifically for stock, it's, dividend discount model. But the question is, when did discounted cash flow model when come out? When was it first developed, and since when have we used discounted cash flow model? of course, it couldn't have been from ancient Greece or medieval time, because the stock, although there was stock market in uh, you know Renaissance period, right, 17th century, 16th century, but in those days, there was no exact science for valuations. So all these models actually came out in the 1950s, right? And the birth of these discounted cash flow models was, Gordon, right? I forgot his first name, but not Robert Gordon. Um, so then our question is, prior to 1950s, how did they value those stocks? In those days, prior to 1950s, they used, it wasn't really that mathematical, but they used something called, price earnings ratio multiple, price earnings multiple approach, right? So this isn't that much, but since we are out of time, we'll have to talk about this in the next lecture, next class. But then, together with that, we are going back to the return on risk, for the more advanced topics of return on risk. So that will be in the next class. And thanks for watching, and I'll see you guys in the next class. So this is the end of the video.